Hi, everyone, and a very good afternoon to all present here. I'm your host, Khushi Mudgal, and I welcome you all to today's TechGig webinar on getting started with Gen AI from NLP to AI agents and automation. It's an absolute pleasure to have all of you join us today. To facilitate this session, folks, please join me in welcoming our distinguished speaker for today's session, Mr. Diptiman Raichaudhuri, Staff Developer Advocate at Confluent. He is an IT industry veteran with more than 2 decades of experience working at Indian MNCs and global product organizations. He is currently working as a staff developer advocate at Confluent. He has designed and implemented modern data platforms for large scale enterprise use cases. He's passionate about working at the intersection of data, Kafka, Flink, Spark, Kinesis, Redshift, Iceberg, Glue, Hive, Neo4j, Neptune, and AI in LLMs, PyTorch, SageMaker, Vertex AI, Kubeflow at cloud scale, AWS, and Google Cloud. It's such a pleasure having you, Diptiman, here with me today.
Sure. Thank you very much, Kushi.
And now about the session. In today's conversation, we will explore how Gen AI has evolved from traditional NLP techniques to modern LLMs and how this evolution is enabling developers to build autonomous AI agents and intelligent automation workflows. This session will uncover the foundational concepts behind NLP, the breakthroughs unlocked by transformer architectures, and the practical journey from early chatbots to today's production grade AI systems. We will also discuss how LLMs can be integrated into enterprise pipelines, how Model Context Protocol MCP acts as a bridge to AI agents, and what developers need to know to start building reliable and scalable Gen AI applications. By the end of this session, we aim to understand what truly defines the future ready Gen AI stack from models, data, and tooling to deployment workflows and real world use cases. I would like to notify that the session is scheduled for an hour. We'll hear valuable insights from our guest speaker, and in the final 15 minutes, we will open the floor for an interactive question and answer round. Please, everyone, feel free to share your questions anytime in the Q&A window. And with that, let's get started. To begin with, let's take up some poll questions. All of the attendees are requested to vote and let us know your views on the same. So, beginning with the first poll question. On a scale of 1 to 5, how familiar are you with NLP? Everyone can vote and let us know your views. We'll have the poll on for about a minute. And all of the attendees, you all can also put your questions in the Q&A window so that we can take them up towards the end of the session. So we have some votes. All those who are left, you can also let us know your views by voting on your convenient option. Okay, so we have the maximum votes for 1 and 3. All right, now moving forward to the next poll question, which is, what is your stream of work within an organization? And the options are number 1, tech support, then there's application development, business analysis, AI, and quality assurance. We do have the maximum votes for application development.
Okay.
for this one. All right, now for the next one, the poll is that are you familiar with NLP tasks? Yes or no? You all can let us know your views. And of course, we have uh, the insights from our guest speaker today to enlighten you on the same. Everyone is requested to vote, so we have a better idea. I can see the votes are increasing. And yes, so for this, we have 65 percentage for no and 34 percentage for yes.
Okay.
All right. So the next question is that are you experimenting with building AI agents? And you have to answer in yes or no. For this, we have a greater percentage for yes.
Okay.
Then moving forward with the next question, which is which LLM do you use the most? And the options are OpenAI GPT family, Anthropic Claude family, Google Gemini family, or fully open source models. They're getting the maximum engagement on OpenAI ChatGPT now.
All right. Okay.
Yes, and the other ones have a lesser percentage, which makes us move towards the last poll question for the session, which is do you code assistance while developing software? And if yes, then which one? And the options are A, Copilot, B, Claude Code, C, Cursor, D, Replit, and E, something else. As this is the last poll question, I would request all the attendees to vote and let us know your views, post which we will be moving forward with the presentation and the valuable insights from the guest speaker.
Yeah, this question is about which code assist do you normally use? Is it GitHub Copilot? Is it Cloud Code? Is it Replit? Is it Cursor? Or is it something else?
All right, so for this, we have the maximum percentage for Copilot
Okay.
and the second highest for Cursor and something else. And
Okay.
it
Sure.
goes on like that. All
Perfect.
right. So we are done with the poll questions and we know some of the opinions of the audience and attendees. And now, Diptiman, I would request you to take it forward from here.
Absolutely. Thank you very much, Kushi. And thank you to a big thanks to TechGig as well for letting us use this platform where I would take you through a journey of how natural language processing started and then slowly how do we move forward. So, as Kushi mentioned, I'm Diptiman. I'm a developer advocate at Confluent. And this session is a quick journey from natural language processing to AI agents, which would involve a little bit of an exploration of the evolution of generative AI, right? So let's get started. I have five sections really, but the first four sections are quick brush up of theory, a little bit of a theory, a little bit of a jargons that we use, so that it becomes a little easy for all of us to sort of slide into this whole motion. But the last one is what attracts me the most, and this is the execution part. How do we use all this in practice? I'm a data engineer. How would I use it? You're an application developer or an AI engineer. How would you use it? So the last section is pretty long. If time permits, I will also show you code, but that's how the whole thing is, right? So let's get started. A quick refresher on natural language processing or NLP. It's nothing but when a computer program which uses mathematical models, mostly deep learning models, it starts understanding human language, the language that we normally write. There are occasions when the language that we normally speak is also understood, but then there are various nuances. There are nuances into the difference between the language that we write and the language that we speak, and we'll talk about it a little bit later. But long story short, the bottom line is we would have deep learning models which are nothing but mathematical models, statistical learning models, which interpret, manipulate, and comprehend human language, right? And for today's discussion, we'll focus on English, but similar concepts could be extrapolated to Indic languages, the languages that we speak in India as well. We have many such languages, I think more than 20, if I'm not wrong. And those are a little bit different as well. The glyphs are different, the phonemes or the sounds of those languages are different from let's say English, which has evolved from Latin as well. And the byte size which is required to hold the characters is also different, right? English, you could probably get through by having those 255 0 to 255 ASCII characters, which would need a single byte unibyte kind of a mechanism. But then for East Asian kind of languages, Chinese, Japanese, you would still need 2 bytes, etc. But then if you keep all those things aside, it's language processing by a mathematical model. And the use cases are language translation, search results, text prediction, text classification, etc. Understanding what text means. That's what NLP is all about. Now, NLP traditionally had these kinds of tasks. So you would have a sentence segmentation where any set of paragraphs would be broken down into sentences. First sentence and last sentence would be figured out, extracted, etc. Similarly, word tokenization, where a sentence is broken and split into words, and the tokens are, of course, tokens in LLMs have started meaning something different, but then if you go to the root of it, it's how do I split words in a sentence? Now, you could split it with spaces. So, I am a boy. So, there would be a space between am and I and am and a and boy. So, we could very well use a space as as a delimiter for tokens. We could use full stops as delimiters for sentences, but then that might work, might not work. There are chances. If I write at etc etc and then put three dots, then what, how do you interpret it? All those things come into being. So regular expression where you can actually probe and find patterns in characters also make it very very important in terms of doing these kinds of tasks. Word tokenization, the rest of it, I'll just go through very quickly. Named entity recognition, part of speech tagging, and co-reference resolution. So these are all classical natural language processing tasks. So sentence segmentation, I already told you. So this is one sentence, and I'm using, by the way, Spacey, which is a very advanced model-based NLP framework. It's fully open source. You could use it right now. I mean, if you go back. So this sentence, it breaks it down, and you could see it has broken down with space as the delimiter, and then it's able to figure out these sentences, and you could print the first one and the last one, and the how does it start and end and all those. So this is what sentence segmentation is all about. Named entity recognition comes in when you have sentences or group of phrases and you want to pick out what kind of a named entity it is, what kind of a noun is it. So seasonal stock associate jobs in Atlanta would actually give you seasonal as a job category, stock associate as a job type, jobs as the query type, and the location. Similarly, I could have a sentence like Aadhaar, I did not want to expose my Aadhaar. Now, Aadhaar would actually be tagged as a personally identifiable information entity. So that's what named entity recognition does. If you train your models well, it can go deeper and figure out all these NERs from the text. And you could do various different things like whether any text contains a personally identifiable information or not, PII or not. With DPDP, the data protection bill that Indian government has come up with, these are becoming very, very important nowadays. Pause tagging is part of speech tagging. So if you have an English sentence, I want to know which one is a noun, which one is a determinant, which one is an adjective, a verb, a conjunction, etc., to figure out maybe which words I might not even need. So a and the, if I'm just want to understand the semantic or the meaning of this sentence, I don't really need the a and the of kind of words. And we normally call these stop words. We would rather remove these words if I want to train a model, right? So this is pause tagging, part of speech tagging. Co-reference resolution is if you have, let's say, a couple of sentences and you have Philip here, Philip and the bass, the instrument bass, and the person Philip. But then in many sentences, all these pronouns would come in: he, him, his, it, which is again a pronoun which associates with the instrument bass. Now, co-reference resolution actually figures out these linkages so that your understanding of that phrase becomes easier. Maybe you want to summarize an email. Maybe you want to summarize a very long financial report. Now, there, if co reference resolution is not done properly, then what would happen is your your summarized version would actually lose meaning, right? So that's a problem. So co-reference resolution is another NLP tasks. So essentially what happens is you put text into these NLP tasks, which is run through your model classically, and then you execute these use cases. You can extract relationships, you can do sentiment analysis, you can understand whether, let's say, somebody is talking to a CRM bot, maybe a CRM agent, and the call gets transcribed into text, and from that text we could figure out whether the person who was talking the other end, the customer, whether the customer is feeling negative or positive about the company, etc. Entity extraction, as we talked about, and topic modeling. So if we have a lot of different sets of sentences, how can we group these sentences into similar groups? That's what topic modeling is all about. So essentially what happens is text comes in, NLP tasks execute, and then you get all this as output. Now, just as text, you could also pass in audio and video as well. And I would get to the point where we would understand what exactly does that mean a little later. Broadly, NLP has two categories. One is the natural language understanding, or NLU, which I talked about, the phonology, the morphology, the semantics of any language. So English, you would go back and you could have apply something known as lemmatization to figure out maybe a verb, to figure out what the exact root verb is from a verb form, and sorry, and then understand the context behind it, right? Morphology talks about the structure of these words and how these have evolved. Semantics tries to learn meaning of each words and phrases together with a defined set of metadata about these sentences. With that metadata is called ontology. Anyway, so that's the natural language understanding bit. Natural language generation is when you can generate text generation part of it, which we do it a lot today with LLMs. Normally, traditionally, classical NLP models were built using a pipeline. So all these text inputs would come in, and tokenization, stop word removal, lower casing, this would be done. And then these text which means nothing to a mathematical model, would be converted to a set of numbers. And we would go deeper into how that's done. But then this whole TF-IDF bag of words, word to vec, and embedding is the process where you get the meaning out of those text and somehow map it with numbers, which mathematical models understand. Um, Similarly, we would do feature extraction as part of it, and then um, parsing of that syntax, the sentence syntax, co-reference resolution for understanding what the text is. Then we would build our ML model. So the model could be built with, let's say, PyTorch, which is again an open source framework, very popular one nowadays. And you could build this whole model using deep learning techniques, etc. And then you do the post processing, figure out whether the evaluation is, whether the model is giving you right results and stuff like that. So most of the traditional NLP tasks, or even today, if you are building such tasks using modern LLMs, etc., would follow this kind of a pipeline, which we call, a pipeline of NLP tasks. Any NLP project would go through this. So classical NLP frameworks, Natural Language Toolkit, NLTK, Spacey, GenSim, which is very, very powerful. And then, of course, Hugging Face, which is sort of a marketplace, an open source marketplace where there would be a lot of models there, and you could play around with those models. And then those models are built with, let's say, frameworks like PyTorch, right? So this has been the tool and framework of choice before the advent of LLMs. Now with LLMs like GPT and Claude and Gemini and all these things coming in, what has happened is many of these NLP tasks can now be implicitly be done by these LLMs. So you don't need to train a model and do all sorts of different steps. You can just ask the LLM that, can you do co-reference resolution? Can you do a sentiment analysis for these three texts that I'm throwing at detail? And it would give you the result. How it is done, we'll go through it shortly. But then this has been the tool and framework of choice before the advent of LLMs. And with advent of LLMs, we have models like GPT and Claude and Gemini. So it's quick refresher on NLP. Now let's understand, with those early classical NLP models, what were the business use cases? So the first thing that came up was chatbots. And with chatbot, Amazon Alexa, Google Nest, so these actually had this framework like Amazon Lex, which actually powers Alexa, and Google Dialogflow, or Rasa was a very, very prominent chatbot framework. And essentially, all of these would translate and map to an application like the image on the right hand side. So you would probably chat with your bank through a chatbot, and you would ask, okay, this is my customer ID, can you tell me if I can get a loan, or stuff like that, right? So FAQ bots became very, very popular. So I would give you an example. Let's say for a metal industry or a steel industry, you have thousands and thousands of distributors who distribute many different things, so that the steel maker can actually get those things through their procurement channel and then do the manufacturing of steel, right? So there, for all these suppliers, they have separate applications, right, where I would download the prices and then upload contracts and all those things. So FAQ becomes very, very important. If I'm a new distributor, new supplier for this steel company, an FAQ bot would be very, very helpful. Otherwise, I would need to go through, let's say, a 500-page PDF with for all the legal contracts, etc. So there, we saw a lot of implementations of FAQ bots, chatbots, to be honest. Let's say banks and all those things. So these were the first generation NLP, I should say, business use cases, which actually saw the light of day. And if you go double click a little deeper into what a chatbot is, what you would see is whatever the user is saying is mapped. So those words and phrases are what are called as utterances, and within the chatbot there are intents. So the model actually maps those utterances with the intent, which ultimately leads to the fulfillment of the question. And there are many parts to it. So ASR is automatic speech recognition, which understands the speech and then creates a speech to text model out of it. TTS actually does the opposite of it, so it turns text to speech if you want the bot to talk as well. And then, of course, for placing in variables like time and place and number and code and ID, etc., you would have something like slots. So with utterances, slots, and intents, you would build the bot to drive the discussion and the conversation to a fulfillment. So that was the broad architectural framework, and most of these chatbots followed the same thing. So Lex and Dialogflow and Rasa were no different. They all followed similar kind, maybe a little different, but then similar kind of an architecture. This is specifically for Lex, though. And this would be for an AWS use case. This would be a very common deployment scenario, right? So somebody would send a customer would send an SMS, and that would be intercepted by an maybe an inbound digital marketing channel, and then it would go through this whole Lex and the processing of Lex, and then it would figure out from some database about the customer and stuff like that, and then give it back. I actually picked it up from AWS. The source is also there. So these were the early generation of NLP tasks. Now, transformers, which actually started with the 2014 paper, and then in 2017, a seminal paper was published called Attention is All You Need, where this attention mechanism came around, and it actually transformed the whole NLP landscape or the language model landscape on its head. So we won't really go very deep into what a transformer is, but let's understand a little bit of the nuances. And for that, what we really need to understand is how these numbers are created from the text. So let's say I have a machine learning is amazing, which is a sentence that goes through an embedding process. That embedding gives me set of, let's say, arrays of floating point numbers, and my model would know how to place these numbers according to the similarity of other words and phrases, etc., in some latent space, in some vector space, so that we could run search operations on it. In vector space, search operation takes different meanings, right? But then it could be as simple as the distance between 2 points within a vector, or the distance between two planes within a vector, which is a line, or distance between two hyperplanes where there are multiple dimensions involved. Now, the whole point was making sure that the model knows how to transform these texts into numbers so that we could do search and reasoning with it, right? So that's how the embeddings got created. Embed, what does the meaning embed is? Embed the whole semantic, the meaning representation in vector space. That's why it is called embeddings. And vector, because it's a vector space, right? So vector means something which has a direction and an amplitude and a magnitude. So with all these words and the kind of numbers that we create, that also has that. So as I told you, it could be done with text. It could be also done with audio or videos. So you could create embeddings out of audio. You could create embeddings out of video. For audio, what we could do is we could take maybe the beat, the pulse, the frequency of the sound, the wavelengths, the waveforms, or something of that sort, and then convert it into numbers. So there would be models for that. So there would be audio model which would convert this, maybe an MP3 or a lossless or a WAV kind of a file into this audio vector embeddings. So let's now quickly compare, right? So I had the text classification pipeline, which would remove words and pre-process and then go through creation of these embeddings through traditional classical means like TF-IDF. And I have another slide for TF-IDF for that as well. And then build the model. So TF-IDF is a term frequency and inverse document frequency, which works very well for search, syntactic search. So when you search something on, let's say, Elasticsearch or Google, maybe the syntax of the phrases uses TF-IDF heavily. And then maybe some other day we could talk maybe for 1 hour on TF-IDF. But then the whole point is to focus on the phrases and the text, and then return what are the terms which matches with those phrases, right? But the problem is those phrases would only work with tokens. So I love machine learning. So each of these words would be searched syntactically. But embeddings would actually create dense vectors, which means non zero values, where you would be able to embed a lot of the meaning of the sentences as well. So I love machine learning, although I haven't really I'm still at standard 7th. Doesn't really make any sense. So all those things could be put into these embeddings. So the idea is to box in the reality as we see in vectors. So
Diptiman, just wanted to mention that we have completed 30 minutes of the session.
oh, we have completed. My goodness, I'll go a little faster. Yeah.
Sure.
So dense vector is what we are looking at. And then what happened was these models started coming out. So what to vec was again a paper from Google, where you pass in a set of words and it would give you a vector version out of it. And it followed two models: continuous bag of word or skipgram. For continuous bag of words, what happened was if you give, let's say, a surrounding set of words, it would give you the context word behind it. Skipgram was the opposite. If you give a target word, it would give surrounding words around it. So if I have I drink coffee, I drink every day, and with CBOW, continuous bag of word, you could get maybe the target of coffee, which would come in as your last deep learning layer. Um, a multi-class classification, if I might say so, with softmax. And for skipgram, what happened if you give and, it might give you these words like abandon, ability, able, and zone, right? And then this thing came up, which was the father of it all. It's the attention mechanism, the transformer architecture, where we have an encoder block and a decoder block. I pass in my embeddings, my word embeddings, vector embeddings, along with the position as well of some of these sentences, so that the meaning is also stored. And then it follows these two large networks, neural networks, and then it gives me back, let's say, how are you doing? I'm good, right? And then I am good, and you, how are you doing? So today is not the day, and the math is not very difficult, but then it takes a long time to decode and explain everything. So this actually changed it, right? And essentially what we did was, you pass in an input, it goes through an embedding and a position and encoding and encoder, and then the encoder feed forwards to decoder, and the decoder gives you the output, right? So that actually gave rise to large language models, or foundation models, as we sometimes call it. So on the left hand side, what you see are the traditional deep learning models, but on the right hand side, you have foundation model, which is trained with huge amount of unlabeled data. And then one foundation model would be able to do all these tasks, rather than creating different models for different tasks. So that was the main difference. And the whole operation would work on an API. So how do you work with LLMs? You pass in a prompt, or maybe you fine tune if you really need to align to your company domain. And then, of course, retrieval augmented generation and all these things are also there. So these are some of the LLMs. I don't need to explain anything. All of you would know. But remember, these do not come for free, except probably Quen and DeepSeek, although you would need a very, very high configuration PC to run this. But yeah, these are the LLMs, right? So now let's understand. So this is now the last thing, which is very, very dense, but then let's understand what this is. So with LLMs we have this prompt, and the LLM answers with a response, right? So this establish a protocol, just like a REST web service. You would have a client which would ask something on an HTTP request, although absolutely deterministic. The URL and the query and the body, post body, it's everything goes in, and the server reads from the REST endpoint, gives you back the JSON, right? Now the problem arises if your LLM has multiple tools to call, maybe a RAG, maybe a web search, maybe an API. Then what happens is, if your tools change, your implementation for calling that LLM also needs to change, which is undesirable. That gave rise to this protocol called MCP, or Model Context Protocol, which abstracts out the tool calling bit from the LLM. So for the invoker, which might be an AI agent or maybe a web service, every web service, what I believe, would have some agentic capability in days to come. So they can only talk MCP. How does it work? So you instantiate an MCP client here. MCP host would be the agent. The MCP client would call the MCP server. The MCP server would call this database or service or whatever. This is deterministic completely, the tool calls. How does the data flow work? I ask a question. Sorry, I ask a question. The MCP client loads all the capabilities of the tool from the MCP server. My LLM helps me map the question to the specific tool which I want to use. I call the tool, the MCP executes the call, gives me back the response, right? This is what it is. So it just abstracts out the tool calling bit from the AI application part. So an example is something like this. Let's say you have a Confluent Kafka server on cloud and a Confluent MCP server running locally on my laptop. I could have an agent, or this is a cloud desktop, and I could ask questions and it could give me answers. So, how would it work? The Kafka MCP server, which would run in my local host, would intercept these questions from the MCP client, establish connection with the Kafka cluster, and send me back details, right? So, let's say if I ask something like my orders topic, I'm seeing some lag in consumption. Can you give me the reason? And then it could do a tool call through my Kafka MCP server. And this part is completely deterministic, by the way. There is no LLM involved. And then give me back the response while the LLM would contextualize and make it pretty, and then give me back the response. So it was released in November 2024 by Anthropic. It just exploded. Although what I have seen for the last 1 year is most of the implementations are in-house. So it is intranet is what is happening. That's the MCP server zoo. So you could just scan it and you would get a lot of details. What we build with MCP are tools which actually would do the execution which the LLMs are asking for. You could also build resources and prompts, but that's not something which you do maybe a lot. Major players, OpenAI adopted the protocol in March. Google DeepMind adopted it. All the developer tools like Copilot and Cursor and Replit, everybody uses it. Python has a very good SDK framework called Fast MCP. It's very easy, very secure, scalable MCP clients and servers you can build with it. So the benefit is scalability, standardization, reducing duplicate development effort, and vendor lock-in. So I have written a pretty long series of blogs on MCP on Medium. So you could just scan this and get through some of these, and you would get to learn. You would be able to run it on your laptop actually. Now that we understand LLMs, NLP, little bit of MCP, I know it's fast, but then little bit of MCP. Let's understand how AI agents would actually work. So, what are agents? Again, a question which gives rise to a lot of debate and discussion. But long story short, it could be some sort of autonomous system, semi-autonomous or fully, versus let's say some workflows which we would run, right? And essentially, what would happen is you give it a task, it perceives what the task is, and then it delivers an act on it, right? So these are all bounded, like absolutely clear what to do. And then within the agent, what happens is this plan and reflect loop keeps on happening, which uses memory and retrievals and retrieve memories. So that's the basic anatomy of an agent. There are many frameworks. So Google ADK, LangGraph, Agno AGI, AutoGen, Microsoft Agent Framework, Strands Agents, AWS, very favorite of mine, Crew AI, etc. But our job is to figure out deployment use cases, because the marketing is absolutely real and it just absolutely blinds you. So what I suggest is you go through this one page HTML from Anthropic called Building Effective Agents, which is absolutely phenomenal. And I think it it is the only seminal document which tells you the patterns of agent interactions. And they start with the fact that you can augment an LLM first, even before you want to go through, to an agent route. By having the LLM call tools using MCP, it can query using RAG, and then it can read and write with some sort of a memory, and then it starts going through these patterns. So let's say prompt chaining, which is a very good for tasks where you could have some sequence, right, where subtasks could be easily be decomposed by the LLM. One example could be generate a document and then create multiple translations of it. So LLM call would come in, and then the gate there would be a decision block, and then some LLM would go to maybe another route and create another set of language translations. The second would be the opposite of it, routing. So I would have a call router and it would route the calls to different LLMs. So very common example would be ticketing. So whether it goes to L1 support, L2 support, L3 support, or maybe whether it goes to CRM or inventory or reservation or procurement, those kinds of things, right? It could be parallelization as well, whether I have created a code and I want to check in, I raise a pull request, but then there are three agents which one checks for vulnerabilities, one checks for different prompts review. So this could all work together and give me back an aggregation. Pattern 4 could be orchestration workers, where I have an orchestrator agent which takes in the input and then um, delegates them to worker LLMs. And those agents does their job. And then there is a synthesizer agent which takes all this input and give you back. And these are all that's all there in that Anthropic document. Please go through it. Evaluator optimizer is again one good one because it actually lets you evaluate. It's sort of a self-healing agent kind of a solution where the agent output is actually evaluated, passes through an LLM as a judge evaluator, which is not fine tuned, and then it goes through the loop again if in case of there is any rejection. Um, Out of those frameworks, AWS Strands is something which I use very often, so I would talk about it a little bit here. But then LangGraph is also very popular. You could use those. A Microsoft Agent Framework is also very popular. So in Strands, what happens is whole tool introspection, figuring out which tool to use, etc. That all happens inside the agent loop, which makes it a little easier to do. So if you double click, what happens is the agent takes a prompt, the agent invokes the model, uses MCP or any other tools, and gives you back the response. So a common example would be this, right? So I would have maybe a Kafka agent where I'm getting real-time data from order creation. I would have a DuckDB agent which is sitting on top of, let's say, a Snowflake database, a data warehouse, or a Databricks data warehouse, Iceberg files, which has all my historical orders. I would have an orchestrator agent which could take input from these two agents and give back answers to, let's say, a question like, can you tell me what is the trend of order creation for the last 30 minutes and the historical trend for the same store for the last 6 months, something of that sort. If you want to have multiple agents deployed, so aws has something called agent core. Similarly, Azure has something, and Google Cloud also has something, which is actually a good infrastructure for deploying these kinds of agents. So you have memory and RAG and profiling and planning and evaluation, observability, all baked in one single system. um, so that's it. I am what, like 40 minutes. So the takeaways for today was NLP task, the need for transformer vector embeddings, little bit of an MCP, and agent frameworks. Before we and of course the key takeaway out of all those takeaways was the possibilities. I want you to go back and start working on it, start experiment, and maybe you try out some new things on your laptop. You don't need to go anywhere else and do this. Before we take questions, I would quickly want to show you, let's say, how this MCP servers work, etc. And at the same time, I could also take questions. So Kushi, if you can read some out, I can take it.
Yeah, Diptiman, definitely. So, of course, these have some amazing insights that we've just, taken ahead from. And you've shared such forward-looking perspectives on how GenAI is reshaping developer workflows, redefining automation, and also unlocking some new possibilities through intelligent agents and also the cloud scale systems.
Right.
And now, as we've received some excellent questions from the audience, we'll take a few of them, which are also available in the question panel for your reference. I'll read it out them for you. So the first question is that how can developers transition from building prompts to building full AI agent systems?
Yeah. So So I think, as I showed you, so you got to understand that LLMs would take prompts and give you back maybe a response, which is fine. But when I'm talking of agents, you need to first figure out what the problem is, which you really want to digitize and automate and run it through agents, so that it is almost like a semi-autonomous kind of a work where you don't need to do anything yourself, but the agent would be able to do. I think that finding out that problem space is first, and then taking your existing skill of, let's say, using some framework of your choice for LLMs. Very rarely would you call LLMs directly raw using, let's say, OpenAI or Claude SDKs. There are many instances when you would use some sort of framework like a LangChain or something of that sort. So you should learn that first so that it becomes easy for you to understand the whole mechanics of how LLMs work. And then today, if you want to do it, you need to learn MCP using fast MCP. And then any agentic framework you can pick up. These are all open source frameworks mostly. And then try to build agents for simple things. Maybe agents for you have a small database and you want to query the database about something, right? So you need to have an MCP tool which can do that querying, and then you let the agent talk to that MCP through their language and then get it done. So I think that could be one of the pathways.
Right, Diptiman. All right, so now moving forward with the next question, which is why are transformer based models considered a breakthrough in language understanding?
Well, it's because of the fact of because of the presence of architecture, really. So if you really go back, so it's good that we're discussing this. I was thinking very hard whether I should include it or not. So earlier, so if you look at it, language is nothing but sequences of words, right? So all sequence models, sequence to sequence models, used to follow those earlier recurrent neural network architectures, right? RNNs, as we used to call it. Then, of course, there are various varieties of it. Because of existing problems in RNNs, you could have GRUs, gated recurrent units, and then LSTMs came in, and then LSTM2 came in, long short-term memory, etc. And but with all these, the problem was huge computation and problems, and you won't be able to gather right responses and all those things. So attention, in many ways, solved that problem. So attention architecture solves that problems, and I think that was the most fundamental thing which happened, which gave rise to these modern LLMs, so GPT-4, GPT-5, Claude, Sonnet, and Opus 4, and Gemini 3, and all those things. So I think Transformer actually created that space where you could move out of RNNs and LSTM2s and rely on something like this, where, well, they're not perfect, they're still not perfect, but then at least they could do your work for you. That would be one of the answers.
Right, very well mentioned,
So
Diptiman.
I'll quickly take a pause. So I've created
Yeah.
one Kafka topic where I'm putting in some orders, and these are orders simulated by me, which is coming from, let's say, a retail store. So now what I'll is I'll just go and run the Kafka MCP, which is an open source project. So I would just start the Kafka MCP server. So once it starts, now any agent, whether it's a Cloud Code or any let's say agent framework, now I'm ready to talk. So let's open Cloud Code, and if you open Cloud Code, I hope it works. I mean, demos fail so often for me. Okay, perfect. So let's see. So you would be able to see the tools that I was talking about. So if you click on Confluent, so you have these tools: list topics, create topic, produce message, consume message, all these topics, right? So I can actually ask list Kafka topics from Confluent Cloud. Now what it would do is it would try to, based on my language, the prompt that I put in, it would try to map from the list of tools from the MCP servers, and it has correctly mapped list topics as the right tool. Now it would use the list topics MCP server tool, and it would give me back, and it's absolutely right. So I have three topics. So I have I have three topics. So I have two dead letter queues, one POS topic, and it is full of messages, etc. And now actually we can go on, we can ask many different things. So describe the schema of point of sale topic, let's say. And now, earlier it took the tool list topics. Now it is now trying to search which tool maps my prompt, and it now picked up the right tool, which is list schema. So you understand, the tool selection is where the LLM comes in. You zero in on the tool, and then fire the right tool on the MCP server, and that code is regular code. That's not LLM or anything, that's deterministic. So it figured out the point of sale and gave me, it has a retail store, workstation, operator ID, retail price, when it was sold, and all that. I could actually go on, so I can actually now write, can you give me the best selling workstation? It will do, it will create a Flink statement, it will run a SQL query, and it will give me real time. But let's take some questions before we do all that.
Yeah. All right. So the next question, Shailja is asking that how do you ensure AI agents behave safely when they're allowed to take autonomous actions?
I'm so sorry. I,
Yeah,
I was
I'll
just
repeat
about
it.
to stop sharing. Yeah, I
Yeah,
can see the question. So,
yeah,
uh,
yeah. Yeah, I'll repeat it for you. So the question is that
yeah,
how do you
is
ensure that AI
the last one first, or is it a first one? How does it?
it's the
Is it?
third. It's the third one.
How can I have wire? Okay, how do you
How
ensure
do you ensure?
AI agents behave safely when they're allowed to take? Yeah, yeah, right. So you have to ensure using these evaluation frameworks, security guardrails, and kill switch. So let's say you don't want your AI agent to, let's say, run a Terraform script of its own just like that, correct? So all these evaluations need to be there, which is why, if you remember, if you have just taken a snap of that uh, Anthropic agent patterns, there is a pattern where you have an evaluator and an optimizer, right? So whatever the agent gives you back, it goes to an evaluator, maybe an LLM as a judge, and that checks whether things are all right using guardrails. And then if it's not, it would give you back, and the agent action will not be allowed further, and then the agent sort of recalibrates and does it all. So all these would need to be brought in. You're right. That's very important to have that thing. Shailja.
Yes. All right. So with this answer, we move forward to the next question,
Next
which
one,
is
yeah. Can you share scenarios where LLM should not be used due to risks or limitations? Yes,
right.
absolutely. You, so I think there are two aspects to it. So when you say LLMs, if the LLM is public, absolutely on internet through an API, you need to understand whether your data would be used for training the LLM or not. So that there was a case, if you, I'm not sure if you know, there was a case where Samsung data was actually public. It went out for LLMs, etc. So you got to have those guardrails, absolutely. And if you ask me, if I'm a businessman, if I have a business, I would rather deploy LLMs in a completely air gapped, walled um, sort of a setup, which you can do it with all three cloud providers, AWS, Google Cloud, Microsoft Azure, as well as OCI, is what I believe. So your LLM should be absolutely in an air gap where data comes in, data comes out, but then no data. So data exfiltration controls need to be there. And if you're putting it in within your internet, there's no chance of exfiltration. But um, so so that's like one aspect of it, the security aspect of it. And the other aspect of it is, would you use an LLM to provide, let's say, a surgeon who is doing cesarean section delivery, to consult an LLM to maybe understand whether the incision would go 3 millimeters wide or 2 millimeters deep? Maybe not. Maybe not yet, unless it goes absolutely in the hands of robots who would be autonomous, and then there would be guardrails within them as well. Today, I don't think those, for those situations. And similarly, you don't do LLMs for, let's say, your bank transactions. You won't like to expose all these things. So those are some of the areas where you would definitely won't want to use LLMs.
Right, Diptiman. So moving forward with the next question, which is what are the core components that make an LLM powerful? Example, attention mechanisms, tokenization, scale,
Yeah,
etc.
yeah, attention, of course. I mean, the way attention works is, it lets you carry the meaning over, and of course there are, if you really study hard, if you really go a little deeper, you would figure out that even within this attention, you would have a decoder only models, which is GPT, and then encoder decoder models as well. And then there's a difference, right? So with decoder only model, you get some sort of output. With encoder decoder, you get a different kind of, but these are all attention, right? So the way attention mechanism is done, and then of course all the policies, which we all the reinforcement learning based policies that is applied, so that the LLM is trained enough to know when it's absolutely talking garbage, etc. So Attention and RLHF, reinforcement learning through human feedback, are two of the most important and powerful thing which makes LLMs
Right, very well mentioned. So, which makes us move forward with the next question, which is by Abiru. He's asking that how API can be used in case of LLMs.
So most of these LLMs, they provide a public API to be used. So you have endpoints, slash embeddings, and slash text generation for GPT. I mean, um, so these APIs could be used through many frameworks like LangChain and other frameworks. If you want, you can do a curl. If you're okay, you can do a curl. You can just paste the body through Postman or something of that sort, rester, and then it gives you back a response. But normally you would find that people would use some sort of a framework like LangChain or um, semantic kernel or AutoGen. It comes to my mind very very often, and not use the regular REST API as we call it. So you would normally use it within a framework. But yes, APIs are absolutely there, and you can use these APIs for LLMs.
Yeah, that's a very great insight to mention right now. So, which makes us move forward with the last question for the session, which is what are the biggest misconceptions that business leaders have about AI deployment?
Well,
Interesting one. Very
yeah.
good.
So I mean, let me be candid as well. So I'm tech,
Yeah.
deeply tech. I'm not into business, but what I would assume is, so AI, just for the sake of somebody else, the person standing beside me is doing AI, is not going to solve all your problems. And what I really feel is, if you want to do good AI, you need to have very very strong control over your data, because you won't be able to run AI models, even LLMs, if your data is not so good. So the first focus would be data, and then AI deployment in certain tasks have been phenomenally good. So language tasks, where sequence to sequence things matter, I think we have reached a fantastic place. Still some rough edges, but I would say language is something where there has been the most predominant work done. Image is also something where we have made a lot of progress. If you look at these car commercials which come in newspapers in India, you would see those term called ADAS, ADAS 2, ADAS 3. It actually means active driver assistance support, which is, let's say, there would be a onboard computer which would look at your eyeballs, and it would try to figure out whether you're falling asleep. So if your eyelids are not open for more than a specific time, more than specific seconds, it would maybe raise an alarm. So these kinds of situations are also good where AI deployment. So image is also, computer vision is also one area where it works very well. Forecasting, etc., is also something which works. Although things like COVID can absolutely throw everybody off guard, but then keeping those aside, you would be able to get a fairly good forecast for retail kind of environments. What I think where business leaders I have seen going a little haywire, a little off from what needs to be done is, when you try to retrofit AI just for the sake of running an AI use case, I don't think it would give you the ROI, return on investment, in long term. So you have to be cautious about it. So that never works.
Right. And that's actually a very absolute and perfect answer that we were looking forward to for this question, which makes and brings us to the end of this insightful session. And of course, there were a lot of questions, but I think all of them have been answered. So, this session has given us plenty to think about, not just the valuable insights shared, but also continuing the dialogue on how AI powered automation, agentic systems, and next gen NLP will influence the future of software development and also the enterprise innovation. So, with that, we wrap up this highly insightful session on getting started with Gen AI from NLP to AI agents and automation. Thank you once again, Diptiman, for sharing such an empowering and thought provoking session with us. It was an absolute pleasure hosting you and hearing your expertise.
Thank you very much. Take care.
And to all our wonderful participants for your engagement and thoughtful questions, which made today's session a great success. This session has been recorded and the recording will soon be available on techgeek.com. Thank you everyone for joining us. We look forward to seeing you again in our upcoming sessions.
Thank you. Bye.
Thanks, Diptiman. Take care. Bye bye.
Take care. Bye.